Yeah, so hi all. Very good evening and welcome back to the third week of TA live sessions for NPTEL Artificial Intelligence Search Methods for Problem Solving. So before we begin, can any of you just confirm is my screen visible and can you hear me properly?
Yes, sir.
Uh, thanks Ankit. Okay, so last week we had discussed some questions from week 2 content, which was mostly dealing with depth first search and breadth first search, and along with that there were uh, depth bound depth first search and DFID as well, which is depth first iterative deepening. And so some of you had requested some examples on DFID to be discussed, and then I had pointed you to some examples that were shared by Bhaskaran sir in the lecture notes. So I hope that helped with the assignment. And if you still need an further discussion on DFID, we can do that today towards the end of the session. Before that, let's finish up the questions from week 3 content, which would be some some new topics. We will see what all those are. So before we start, any doubts that you guys might have?
So, just a general query like for the week two, recorded section was released. Recorded session of this week two was released quite late even after the submission of week two graded assignments.
Uh-huh. Yeah. Yeah.
So, that is a request that because it was required for some of us to revisit some of the things that you help us visit it at that time. So if they are released timely, then that will be great.
Yeah, thanks for the feedback, Ankit. I agree. This time there was some technical issue because of which I got delayed in uploading it on YouTube. But yeah, I will try to get it up on YouTube and the link shared as soon as possible after the live session. So yeah, that shouldn't be an issue from now on. And thanks for pointing that out. Yeah. Anything else? Okay, that's great then. Let's get started with the session then. Okay, so this is something that we are going to see a lot in the coming questions. So this is a map. Okay. Um, okay, let me do one thing. Let me shift to Jamboard and just give me a moment for that. Okay. Yeah. So uh, so thanks for the message. Is my voice audible now? I was on mute for the last few seconds. I hope the voice is audible now.
Yes, sir. The voice is audible.
Okay, okay, thanks. All right, so yeah, so this is the graph that we are going to deal with for the next couple of questions and some common doubts that are usually raised or uh, people usually talk about. I'll just like to address that before we get started with the questions. So here different nodes are indicated or named with different letters, okay? And this one over here, S denotes our start node, and this one over here, G denotes our goal node, okay? And Our objective is to use different algorithms, different methods that we are going to see or have seen before to somehow find a path that is optimal and that goes from this S node to this G node. Okay, that path will be going through some of these edges, some of these other nodes, and we have to find the optimal path. And if you notice, so if I enlarge this thing even more, this image even more, you'll see that in the background there is a map, like a coordinate system given over here. Yeah, let me just erase these marks. Yeah, so can you see these small lines, a bit faint lines in the background? Things like these.
Yeah.
Yeah, so we will assume that each of these small boxes in the background has dimensions 10 units. Okay, you can think of it as 10 centimeter, 10 kilometer, whatever you want to keep it. We are just going to assume that each of these boxes is a 10 by 10 box. And we are going to need this information when we see some of the algorithms that we are going to employ to find the path from S to G. Okay, so with that in mind, uh, let's see the first question. Okay, so the first question is, it says that in the given map or the graph, the starting node is S. What we have to do is we have to use the depth first search method that we saw in the previous week, and we have to list the first 7 nodes that are going to be inspected by this particular algorithm. And this question also mentions the order in which we want to have the answer. It is we are asked to list the nodes in the order they will be inspected. And if the algorithm terminates early, in the sense that if the algorithm terminates before we even inspect 7 nodes, then we just have to list all the nodes that have been inspected up until that point of termination. Okay, so I'll maybe enlarge this map a bit and I'll give you some time to solve it, and then we can have a discussion on this. Yeah, so we already have a couple of answers in the chat, and so thanks for your message, Vasant and Lekana. I was on mute. I was just giving you some time to solve the question. That's why I was on mute. But I hope you can hear me now. So yeah, okay. One other piece of information that I would like to tell you is that, so you remember that. Okay, so which was the data structure that we used in depth first search? Can anyone remember? Yeah, it was stack.
Stack.
And if you remember, we used to insert the elements in the stack according to a particular move gen table that was given to us, right? To decide the order in which we will inspect the nodes. And yeah, one other piece of information in this question that I forgot to mention and would like to clarify now is that suppose we are considering to inspect the first node, we are starting from the starting node S, and there are a few other nodes that we could go to from S, right? So let me just shift to the Jamboard. So if we are at S over here, sorry about that. If we are at S, we could go to E, right? This one, we could go to J, we could go to O, and we could go to K. Okay, so the move gen table will have all these E, J, K, and O as the candidate nodes that we could go to from S, but the order of these would be decided by the alphabetical order. Okay, so that is one assumption that is probably not given in the question, but it's what I am telling you. So that is the order that we are going to follow. So what I mean to say is basically in the first step after S, the next node that we are going to go to will be either of E, J, K, and O, and in alphabetical order, E is the one that comes at the top, right? So after S, we are going to go to E. Okay, is that does everyone agree with that, or is there any doubt about this particular step?
Hello, sir.
Yeah,
Hello. Sir, may I ask you one like, small question? I have only one doubt. Huh?
please go ahead.
Sir, this is a map, okay?
Yeah,
Suppose I am doing, it's a different question about traveling salesman. It's a basic question, hai, sir. Pucho?
okay, but I
Uh,
okay, okay, fine, go ahead and I'll see.
so what happens? Suppose I am starting from source node, okay? And what happens in traveling salesman? The smallest distance जो होते हैं वो लेते हैं और लेके आगे आगे चलते रहते हैं. Yes, sir.
Okay, so what's your
And sir,
question?
if I cannot cover all the vertices in that way, then what would happen?
Then what would happen in the sense that?
Sir, if I am suppose from source node, I'm taking the smallest distance. Suppose एक city आ रहा है A, S से A, smallest distance. तो मैंने A ले लिए. उसके बाद A से P आया, तो P मैंने ले लिए. Okay, P से M आया, तो P से M ले लिए. And in that way I'm going. And if I cannot cover all the nodes, so is it a traveling salesman problem?
Okay, so I think your question is diverting a bit. So I will still address it, but in the meantime, I'll yeah. So okay, so I'll quickly address it. So this is not a traveling salesman problem. Okay,
Okay.
this is not a traveling salesman problem. You are not required to visit all the nodes.
Sir,
Uh,
in traveling,
there.
no, sir, what I'm saying, sir,
Okay,
एक छोटी सी question because I have gone through all the lectures. एक दो छोटे छोटे basic question है sir, बस.
okay. Let me address the
हाँ,
first question, then maybe I'll come to the other one. Okay,
okay.
so yeah, so there are different ways to solve the traveling salesman problem, some of which we are going to see in the coming week also.
Hmm.
Uh, yeah, so if there is a way in which you can go through all the vertices and complete the traveling salesman route, uh,
Okay.
then you will find it using the appropriate algorithm. And if you are getting
Okay.
stuck, then
Okay.
means that that the algorithm that you're using is not appropriate. And if in another case, if there is no particular path that can fulfill the requirements of the traveling salesman problem, then that is the case.
Sir, what
Okay,
happens? जैसे यहाँ पे there is a question जिसमें बोला हुआ था, it means you have to take the edges. You cannot draw any edge on your own. Okay. Whatever edge is given in the map, you have to take those edges. Okay.
sure.
When I was going through the edges, okay, I cannot cover all the edges. When I'm taking smallest distance, I cannot cover all the edges. So I think that's not a traveling salesman problem. Is it so, sir?
Then you'll have to
Because
look
traveling
at the
salesman problem means I have to cover all the ages.
uh,
Once,
are
Uh,
only
you
once.
sure? Okay.
uh,
Okay.
uh,
I
for
would
the sir, can I go ahead, please?
yeah, sure, Ankit.
For traveling salesman problem, it is like that you have to visit n type and nodes. That is definite. You cannot skip any. That is altogether a different class of, you can say, a different kind of problem to that we are solving here.
Yeah, thanks,
Means
Ankit.
I have to cover
That's
all the notes, na? I have to cover all the notes, na?
okay. So, can I have your good name, please, sir?
Huh? Rajesh.
Yeah, Rajesh. So, thanks for your question. So, like Ankit was saying, in traveling salesman problem, you have to cover all the nodes. Okay. So, covering all the edges is a different problem altogether.
I'm
Okay.
not asking about all the ages, sir. I'm talking about the notes. जैसे क्या हुआ पिछले साल ये पेपर मैंने दी थी पिछले साल मैंने I have gone through the assignment. So what happens when I am doing the previous year's questions na? So I cannot get that get all the notes, okay? And still it is saying that the answer is that I got one tour and I there can be more than one tour, but I cannot get a single tour in that question.
Then it's okay.
I think it's better that we discuss that question to discuss for a forum itself, because it is not the question that we are discussing currently.
Thanks for that, Ankit. That I was about to say the same thing. So, Rajesh, I would encourage you to
Uh,
either wait till the end of the live session and we can continue this discussion then, or you post it on the discussion forum and someone will address it. Okay.
no, sir. Then what I will do after this question, can you solve that question? That question is over here also. In this question also, there is a part because traveling salesman, there is one. There will be one question, I think.
No, there isn't, Rajesh. And I would really appreciate if we could maintain the flow of the questions. And maybe towards the end of the session, if we have time, we can continue discussion on that. And
Sir,
when the topic of traveling salesman comes up in the coming weeks, I would be glad to continue this
in the
discussion in
not in the
further
coming week,
detail.
sir. Yeah, we have a question in this week only, and this week only. That means cover all the. Can you find a tour? I cannot find a tour. But when I was solving previous year's question, then also I cannot find a tour. But it is saying that you can find a tour. How is it possible?
Okay,
I
let
cannot find
me.
the tour. Uh,
Okay, that's okay. You cannot find the tour. Maybe there is a different approach. We will discuss that after we complete all the questions from today. Okay.
Okay, sir. Do please, sir. Please help me, sir. Only two questions are left. Otherwise, I have solved every question. Okay, sir.
After everything we have done, after we have done covered every question. Okay. Till then, I would really appreciate if we could continue the flow of the questions that we are supposed to do today.
Okay. Fine, sir. Fine. Okay, thank you, sir.
Okay. So coming back to our question, any doubts about this particular step going from S to E? Okay. Thanks for the confirmation in the chat box. Okay. So now that we are at E, we will see what are the different nodes that we could go to from E. Okay. So we could go to A, we could go to B, we could go to F, and we could go to S, back to S. Okay. But we won't go back to S because S has already been visited, right? And then the next node in line is A, right? Because A comes alphabetically first in the order of A, B, and F. So after E, we are going to A. Okay. Uh, Sorry about that. Okay. Once we are at A, we could go to J or B, right? And we are going to go to B because again it's alphabetical order. And remember that once depth first search starts going down a path, it goes down the depth. Okay, so it won't care about the nodes in the neighborhood. If you also implement it the way that we had discussed in the previous live session, you will arrive at the same answer. But just for the sake of not going through every minute detail once again, I'm just following this simple intuitive approach of depth first starting at a particular node and then going through a particular depth, which in this case is in this direction. Okay, so now we are at B, and the next node that we can go to would be C, right? Because B is connected to E, A, and C, out of which E and A have already been inspected. So next we'll go to C. Okay, from C we can go to F, H, and D. So we'll go to D. because that is alphabetically at the top. So how many nodes have we covered till now? We have 1, 2, 3, 4, 5, 6, right? And we are asked to give the 7 nodes that we are going to inspect. And from D, there's only one way we can go, and that is I. Okay, so our answer would be S, E, A, B, C, D, and I. So let's check that. Okay, so it seems like we have found the correct answer. And yeah, sorry about that. I'll just share this particular tab. Yeah. So any doubts about how we arrived at this particular solution? Would you like me to go through the individual steps again, like in the previous live session?
Could
Or
you
is it
please
clear?
repeat once? Could you please repeat once?
Okay. So thanks, Dr. Ashwini. Okay, I'll quickly go through it once. Uh, since some of you are saying that they are clear on it and some of you want a quicker explanation, I'll just go through it once more. Okay. So remember one thing, that when we are using this depth first search method, what happens is, okay, let me actually draw something and show it to you. Okay, suppose we have a graph like this. Okay, this is the starting node. Okay, again, sorry for the terrible handwriting, but okay. Okay, so we are now at S. Okay, and if we employ something like a DFS method, what it will do is it will start searching in a particular direction. Okay, let's suppose this is the whole graph. Okay, I'm not drawing every node, but there are other nodes in here, something somewhere here, somewhere here, somewhere here, things like this. Okay, suppose it starts going in this particular depth, so it will continue going in that depth. Okay, it will go here, it will go here, it will go here, it will go here. It will continue searching the nodes as per a particular depth, and if it finds a goal node, then good, it will stop, it will terminate, and it will say that the goal node has been found. If it can't find a goal node, it will backtrack. Okay, and it will backtrack, and whatever were the options that it could use, it will go and explore that particular depth. For example, if there was another option that it could take from here, it will backtrack and then it will go from this depth. Okay, and again it will try to find some other depth, and again if it doesn't find, again it will backtrack and go to some other way. Whereas what happens in breadth first search is, if you're starting from this start node, you move around the neighborhood, something like this. You explore the neighborhood first, and if you find the goal node in the middle, then great. Otherwise, you continue exploring the neighborhood of that particular start node until you find your goal node. Okay, so this is an intuitive way of looking at depth first search and breadth first search. So if we just follow that way, what is happening here is, let me erase everything so that we start from scratch. Okay, so we start from this particular start node. Okay, and then what are the options that it could go to? It could go to node E, it could go to node J, it could go to node O, and it could go to node K. Why? Because all these are the nodes that are connected to S. Okay, now in the previous week we were given the movegen table, and according to that we were choosing to push our elements in the stack in a specific order. Okay, in that particular order. Here we are not given the movegen table, but we are told that we can assume that the nodes will be visited in an alphabetical order. So if we had to write our movegen table in this case, it would be something like this. Okay, so this is the node S, and the movegen for X would be E first, then whichever comes in the alphabetical order, it would be J, K, and then this is O, right? Okay, so when you push these elements onto the stack, they would be something like this. O would be at the bottom, then there would be K, then there would be J, and then there would be E. So the next node that you're going to inspect would be the one at the top of the stack, which would be E. Okay, so after S, you're going to explore E over here. And then you're going to repeat the same steps. Okay, so what are the nodes that we could go to from E? We could go to A using this path, we could go to B using this path, and you could go to F using this path. It doesn't make sense to go back to S, so we'll just keep that out of our mind. Okay, so E from E, we could go to A, B, and F. And since A is alphabetically before B and F, from E we will go to A. Okay, again, now we are at A, we could go to J and we could go to B. We'll go to B because B is also J is already a part of the open list in our case, right? If you remember the concept of open list and closed list, so we won't even consider J. From A, we will go to B. Again, from B, we will go to C. So see, it's continuing exploring in a particular depth. Okay, it's going in this direction, it's continuing exploring in a particular depth. From there, it will go to D. From D, it will go to I. And at this point, we have already inspected 7 nodes. 1, 2, 3, 4, 5, 6, and the 7th node. Okay, and that is what the question asks us. We have to report the first 7 nodes that are going to be inspected by the depth first search algorithm. Okay, and we have to report all these nodes in that particular order, and that is what we have arrived at, which is S, E, A, B, C, D, and I. Okay. Yeah, so yes, last year. So we are adding the nodes which are all no, we are following the same approach that we followed in the previous live session. Okay, so if a node is already present in the open list, we are not considering that. That's why when we were at this particular A node, okay, there were 2 candidates that it could go to. There were actually 3 candidates. Which was E, J, and B. E at this point is already inspected, so it would be in the closed list. Okay, so we are not considering that. And J at this point is in the open list because when we inspected S, we already added J to our open list. Okay, so we are not going to consider J also. From A, there is only one way we could proceed, which is to go to B. So it's the same approach that we followed in the previous live session as well. Okay.
How the stack is updated in each stack?
How the stack is updated? Okay, I'll show you one quick example. So suppose when we inspected, so to begin with, we only had S. Okay, so when we decided to
Yeah.
inspect S, we popped out S. Okay, S came out and the stack became empty, and we inserted the neighbors of S in the particular order that we mentioned, which was O, J, or which was K, whichever was it.
Screen is not visible.
Okay, sorry about that. Yeah. So it was something like this, right? It was O, K, J, and E. Okay, and at this point, S is
Yes.
already part of the closed list. Next, E is at the top, so we pop out E. Okay, so E is no longer here. Okay, and if we write down the nodes that we could go to from E, those would be S. Those would be A, B, F, and S, right? Those are the 4 nodes connected to E. A, B, F, and S. Okay, now out of these, S is already in the closed list at this point, right? So we are not going to consider that. We are going to
Is closed list is also a stack?
is what a stack?
Is closed list is a stack or?
Okay, so you can consider the closed list to be a stack. In the previous live session, I had said that it is not necessarily a stack, but depending on the what is the order you want to output your particular closed list elements into, you can either consider it's a stack or not consider it's a stack. The difference would be, so suppose you are just letting things to add up as and when. Okay, so after S you inspected it, so you add E over here. Let's say after E you inspected A, so you add A over here in your closed list. Okay, so this is your closed list. Okay, now when you are asked to output the
Now it
elements
is
of your
clear.
closed list, if your closed list you consider it to be a
Now,
stack, you would be pushing elements on top of each other, something like this. So when you pop out the elements, your output would be in the reverse order. Okay, it would be something like B A E S. And if you don't consider it to be a stack, you just consider it to be a list where this is the front, right? Something like a queue. Then the order of where in which you would be report would be S E A B. Okay, so either is fine. Usually, you can choose to adopt anyway. I usually prefer this way because it's easier to interpret just for me. Doesn't necessarily mean that it would be the same for everyone. And I've also seen that there are some questions where closed list is considered as a stack. So you can consider that also. In fact, if there is a particular way that has been prescribed in your assignments, you should stick with that. Does that address your query?
okay, okay. Please continue that stack discussion. Okay.
Sure. Okay. Yeah. So we were at this point where we had to insert ABF, right? So ABF would be inserted this way. You would insert A, B, and then A. So the next time we have to pop something out, A will be at the top and A will be inspected. Okay, and we will proceed so on and so forth. All right. Um, okay. So yeah, Ram, I remember DFID has not been discussed and maybe we will consider it towards the end of the live session. Okay, I'll just quickly check if there are other questions in the chat box. We are going to discuss some questions that are going to employ greedy heuristic, some form of it. So just wait for that. Yeah, no other question. So let's proceed with the next question. All right. So we solved this question using the depth first search method. Okay. Now we are asked the same question. We are asked to report the first 7 nodes that are going to be inspected by the breadth first search algorithm. Okay. And as I explained before, in case of breadth first search, it starts to explore the neighborhood instead of going along a particular depth. Okay, so we again have to report the first 7 nodes inspected. If it reaches termination, we just have to report the nodes inspected up until termination, and the same assumptions hold. The moveGen function will be, the order will be decided by the alphabetical order, and yeah, we have to go for this. We have to start from the start node. Okay, so again, I'll give you a minute, and then you can share
Sir,
your.
hello sir.
Yeah, Ram.
Suppose if he reach the node, then it is taken as a inspected node.
Uh, Once you decide to go from your previous node to the next node, yeah, the current node that you are at that point is going to be inspected. So that's how you proceed. For example, if you are at the start node, okay, you are inspecting it, and once you decide to move from your start node to another node, let's say E node, then you have already moved past S and you are at E now. So now you are inspecting E. Does that help with your query? Okay. Yeah, we are going to use a queue this time, Poonam. Thanks for your question or your suggestion or the suggestion or question in the chat box. Yeah, we are going to use we're going to use a queue because we are going to apply the breadth first search method. And I see some of you have already shared the uh, solution that you have found, and yeah, let's just wait 1 more minute and then we can discuss the solution. Yeah, thanks, Ankit. I'll just zoom on the diagram. Or maybe I'll shift to the Jamboard so that you can see it even more clearly. Okay, so as I see, most of you have already found the solution, and I'm very glad to see that. Um, as we discussed in breadth first search, we are going to follow exploring the neighborhood approach. So once we inspect this particular node S, we are going to add E, J, K, and O in that order to our queue, right? So after S, we'll first inspect E. Then since we have employed a queue and not a stack, we are going to then inspect the next element in the queue, which would be J alphabetically, right? It would be then after J, it would be K, and after K, it would be O, and after O, it would be the elements that were added when E was inspected, right? And those would be A and B in that particular order. Okay, so at this point, we have already inspected 7 nodes, which is what the question asked, and the order is S, E, J, K, O, A, and B. So let's quickly check the solution.
Sir, can you repeat the solution, sir?
Sure. Okay. So what do we do in case of a breadth first search? We follow a queue. Okay, let me clear this. Okay. So consider this is our queue. Okay. We are inspecting S. Okay. And the nodes that we could go to from S are E, J, K, and O. Okay. We could go from S to all of these. So we are going to insert these in our queue in this fashion. Yeah, I would request you to mute if you don't have a question. Yeah.
काय जास्त एक्सप्लेनेशन करत बसायचं नाही आणि बाजूचा फापट पसारा अजिबात डोक्यात घ्यायचं नाही.
Okay. So
लक्षात ठेवायचं दुसरं काय बघायचं नाही.
I would really request that you mute yourself if you don't have a question. If you have a question, I would also prefer if you speak in English because then I would be able to understand it. And yeah, that's it. Okay, so from S we could go to E, J, K, and O. And this is the order in which we are inserting this into our queue. Okay. Now, remember this is the front end of the queue and this is the back end or the rear end of the queue. So after this, the next node that will be inspected would be the one that is at the front of the queue, which is E. And when E is inspected, remember from E we could go to, sorry about that, A, B, and let's just see A, B, and F, and S as well. But S has already been inspected and it's a part of the closed list, right? So the nodes in a queue would be something like this. A, B. Let me just erase this so that it doesn't cause any confusion. A, B, and F. Okay, and at this point, E has already been removed. So once E has been inspected, although A, B, and F were added to the back of the queue, the next node that would be inspected would be J, because that is at the front of the queue now. Okay, so we will proceed in the similar fashion, which is what I was explaining when I said that intuitively we were going to explore the neighborhood, right? So when we apply breadth first search, we explore all the nodes in the neighborhood of that node, and then we proceed to the other nodes that were in the neighborhood of the second node. Okay, so from when we start from S, we go to E, we inspect E. After E, we inspect J. After J, we inspect K. After K, we inspect O, and then we arrive at inspecting A and then inspecting B. Okay. Okay. Okay, so those of you who were asking questions in the chat about the heuristic function, we are going to discuss heuristic functions in a while, so please be patient. Yeah, so it seems like one of your colleagues' question has already been answered. By one of your colleagues in the chat box. We are inspecting E before J because we are considering an alphabetical order. Okay, so Rocky is asking if there are no nodes connected to E, then it would be the next node that is J, right? So, okay, so I'm not really sure what you want to ask over here. See, once you inspected S, you already added E, J, K, and O in that order. Okay. So if there is no particular node that is connected to E, irrespective of that, you are going to inspect J next, right? Because that is at the queue, in front of the queue once E is inspected and E is taken out. And then maybe the nodes that are connected to J will be get added to the back of the queue. Yeah, whichever is in the
Move
first
on.
of the queue, that will be
Yes.
inspected. Okay, so Ankit Mane. So I'm not sure if there's you're by mistake unmuting yourself. So if that is the case, then I would really request if you can be careful. But if you have a question, please feel free to unmute and say it clearly. Okay. So if you unmute and then quickly mute yourself, you say something, it's not audible to everyone. And I also don't understand. It's not really helpful for anyone. Okay. All right. So I hope there are no doubts about this particular question. If that is the case, we can move on to the next question then.
So what is the answer? Condition.
Yeah, so the answer for this question is S, E, J, K, O, N, O, A, and B. That is the first 7 nodes that we have inspected using breadth first search. Okay, also just to clarify, those who are raising your hands, since I'm shifting between tabs very often, I'm not always able to see whether you have raised your hand or not. If you have a really important doubt, you can please unmute yourself, okay? Please don't wait for me to see the raised hand option on the Gmeet. So, Viresh, you had raised your hand. Okay, it seems like it was unintentional, so that's fine. Let's move on to the next question then. Okay, so now that those of you who were interested in knowing about heuristic value, now we are going to discuss that. Okay, so so each of these nodes in the map or in the graph, we are going to assign it a particular value. Okay, so now we are moving on from the methods that we discussed, which is DFS and BFS, and now we are moving on to heuristic based methods. So what we are going to do is we are going to assign each of these nodes a particular value. Okay, and that value is called the heuristic value, and that will be decided upon the conditions that are given to us. So in this particular question, we are told to follow a Manhattan distance approach. So what is a Manhattan distance? I'll quickly explain to you. Let me just erase the other things. Okay, so this is the point where this assumption that I told you to make about each of these small boxes in the map being of 10 by 10 units, this is where it is going to be useful. Okay, so when we are asked to find the Manhattan distance between 2 points on this particular map, let's say our first point is the S node, okay, this one, and the second point is the K node. So in Manhattan distance, what we can do is we can move according to these particular small blocks. Okay, in the sense that when we have to measure the Manhattan distance between S and K, we see that there are 4 small blocks between S and K, right? Which is this one, this one, this one, and this one. Okay, so 4 into 10, 40 is the Manhattan distance between S and K, and that is the value that we are going to assign to K. Okay, and this need not be measured in the horizontal fashion. Okay, suppose you are asked to find the Manhattan distance between G and Y. Okay, here you see there are 3 boxes. One is this one is this one, and one is this one. Okay, so 30 is the distance between these two. Okay, but when we are defining the heuristic value, we are going to define all of them with respect to a particular node, because that will make it easy for us to decide which node to go to once we are at a particular node. Okay, so let's get back to the question.
ऍसिड हायड्रॉलिसिस आणि अल्कलाइन हायड्रॉलिसिस.
Okay, so I'm really sorry about this, but Ankit, I think that I have to remove you from the meeting, and I really hope that this doesn't happen again. Okay. So sorry about that. Let's get back to the question. And yeah, so here we are going to define the heuristic value with respect to our start node. Okay, so basically we are going to find the heuristic value starting from the S node. Okay, so think about what will be the different ways
Excuse
in
me,
which.
sir.
Yeah, Ram, please
Hello,
go ahead.
sir.
Yeah, please go ahead.
Actually, heuristic value is with respect to goal node or starting node, sir.
Okay. Yeah, thanks for clarifying that, Ram. Yeah, it is with respect to the goal node. My bad. Okay. So basically, yeah, sorry about that. I think I was just distracted a bit. So yeah, that makes sense. We are going to define our heuristic function with respect to the goal node, because we eventually want to find which node is getting us closer to the goal node. Okay. So for example, if we have to say what is the heuristic value of, let's say, M. Okay, this particular node. So if we have to reach from M node to the goal node, we can either take this route. Okay, we can go one block to right, another block to the right, then we can go one block up, again one block up, and again one block up. Okay, that makes a total of five boxes, which is 5 into 10, which is 50. Or we could also go this way. We could first go up one block, up one block, up one block, another block, and another block to the right. We still reach the goal node in 5 blocks. Okay, so which again makes 5 into 10, 50 units. Okay, we could also do it this way. We could go right, we could go up, up, right again, and then again up, and again we are using the same 5 units of 5 boxes. Okay, 1 2 3 4 5. So irrespective of whether you go right and then up, or up and then right, or you just go a staircase manner like this, you are going to have the same heuristic value. Okay, so that makes it robust. So the heuristic value for M would be 50. Okay, let's find the heuristic value for all the nodes in a similar fashion. And
Sir,
then,
sorry to disturb, sir.
yeah, please
So
go ahead.
isn't it that we need to move from one node to another, or directly we can use these boxes to reach to the goal node?
No, no,
I
no.
have a doubt.
Yeah, that's a valid doubt. So thanks for asking that. When we are calculating the distance between two nodes or the heuristic value between two nodes, we are not actually moving. Okay, we are just assuming that this is the path that could be followed. Okay, we are not actually moving from that node to the other node following the boxes. Okay.
Okay, thank you, sir.
Yeah, we are only going to move through the edges. Okay. Okay, so I see some of you have been asking some questions in the chat, and yeah, so just to address your doubt, Hemant, we are going to, since we have already moved on from DFS, let's keep those discussions towards for the end of the live session. Okay, uh, let's continue, and once we are done with discussing all the questions, if we have time left, we can always revisit the questions. Okay, because that would be beneficial for the people who are joining, who are like waiting for the questions to be discussed, right? So once we have already completed the discussion of the question that we were supposed to do today, we can revisit the questions that need further clarification. Okay, so yeah, that is what the question asks us. We have to find the particular node with the largest heuristic value. Okay, and it is trivial that the heuristic value for the goal node would be 0. Okay, because the distance from the goal node to the goal node is 0. Similarly, the heuristic value for, let's say, y would be 30. Right? The similar for I would be, how many blocks is the distance? It's 1, 2, 3, 4, 5, and 6. So it would be 60. Right? So on, you can find the heuristic value for each of these nodes, and you have to report in this particular question which of them has the highest heuristic value. I'll just leave you with the map for a while so that you can give yourself some time and find all the heuristic values. Okay, so 2 questions. So Kesher asked, but we cannot really move by hypothetical distance. Yeah, so this is the distance. This is how we calculate the Manhattan distance. Okay, that's why we are using this particular blockwise approach to find the heuristic value. We are not actually moving through the coordinate system or the blocks. Okay, and so Rocky asked, what would be the case if we use a Euclidean distance and how to find it? So yeah, we could use the Euclidean distance as well, but in that case, we would be instead of, okay, let me just go back here. So in that case, we would be following the simple, if you remember from our high school mathematics, okay, the Euclidean distance between 2 points of the coordinate system x0, y0 and x1, y1 was root over x0 minus x1 whole square plus y0 minus y1 whole square, right? So we are using that particular formula and finding the Euclidean distance, which is also a valid approach. But in this question, since we are asked to use the Manhattan distance as the basis for our heuristic value calculation, we are going to use that. And then there was another question which asked what do we mean by highest. Okay, so what we mean by highest is that so we saw that G had heuristic value of 0, M had a heuristic value of 50, and 60 had I had a heuristic value of 60, right? So 60 is greater than 50. Similarly, there could be another node in this particular map, let's say, that has a heuristic value of 100 or 200. Okay, so we have to find the one which has the largest heuristic value. That is what we mean by the highest heuristic value. So heuristic value can be defined between one node and any other node. Since we are using Manhattan distance, it need not be that that node has to be connected to the goal node. Okay, that's where I think some of your doubts are coming from. So when we are calculating the heuristic value for M, you see that M is not directly connected to G, but we are still able to find that 50 is the heuristic value, right? By using the blockwise distance measure. Okay, so some of you are suggesting that A node over here has the highest heuristic value or the largest heuristic value, which we would see is the actual case. And let's just, so since some of you were requesting to in the chat box to once again go over how we exactly find the heuristic value, let's just quickly go over that again. So if we have to if we have to traverse through these boxes to reach this particular goal node, how many boxes are we going to have to cover? Okay, so we are going to, if we start from this particular node A, we can go one box to the right, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, sorry about that, 12, 13, 14. Okay, now we go up 15, 16, 17, 18, 19, 20, 21, and 22. Okay, so you can go all the way right and all the way up, or you could go all the way up and all the way right, or you could go something like this as well. Doesn't really matter. Sorry about that. In any way, you're going to have to cover 22 boxes of this coordinate system in order to go from your A to G. Again, this is a hypothetical distance measure, not the actual edges or actual edge defined by the map. Okay, and since we had defined that each of these boxes is of 10 by 10 size, the distance that we are going to have to cover is 22 into 10, which is 220. Okay, so the heuristic value for A would be 220. Okay, and if you actually compute the heuristic value for all these nodes, you would see that A is the one that has the highest heuristic value, which is 220 is the largest value that among any of the values that these nodes could take, all the other nodes could take. Okay, so our answer in this case, for this particular question, would be A, and the heuristic value would be 220, which some of you did mention, and I'm really glad about that. Okay, so yeah, valid question, Monica. If you're not given a map, you can draw your own map. Okay, you can draw your own map. Assume that there is a coordinate system, and you can base your answer based on that particular coordinate system. But that will usually not happen in exams, especially in NPTEL exams. You will always be given the map, because if you're not given the map, depending upon how you draw the coordinate system, your answers might differ, right? And we need a uniform way to evaluate everyone, so you will always be given the map. Okay, so a couple of questions. Okay, so Dakshata, you're asking about the YouTube link that is already available in the Swayam portal. Just go to the Swayam portal and see the problem solving session link. That will lead you to a Excel sheet where the YouTube link, the link to the drive folder where all the slides will be uploaded, everything will be present over there. So just check it out. Okay, so can we go up to J also from A in reverse order? Okay, when you ask about can we go from J to A, what do you mean? Do you mean when you want to calculate the Manhattan distance, or do you mean whether you can go as per the edge? If you're measuring the Manhattan distance, doesn't matter how you're measuring it, it will turn out to be the same. Okay, because you're always have to cover the same number of boxes. If you're asking about whether we can follow the edge, since this is an undirected map, you can always follow any direction that is possible for you. Okay, but whether that will be allowed by the algorithm that you're employing or not, that is what you have to see. Anyway, so we are diverting. Getting back to the questions in the chat box, why can we not take from the start node? So good question. I was also confused about this earlier, and thanks to Ram for clarifying that. It is non-intuitive to take the heuristic value from the start node, because what is the our goal for defining the heuristic values is we want to eventually follow a certain steps that make us closer to the goal node. Okay, and how can we decide whether a node is closer to the goal node or not? We can decide that if the heuristic value is with respect to the goal node. Okay, if it is with respect to the start node, then as we move away from the start node, the heuristic value would be increasing only, right? So you would have no real measure to define whether you are getting closer to your goal node or not. Okay, that's why we have to take the heuristic value with respect to the goal node. And again, thanks Ram for clarifying that. Okay, so Rocky is asking what would be the value of x1, x2, y1, y2 if we calculate using Euclidean distance. Again, if you're asked to use a Euclidean distance, you would be given a well-defined coordinate system where each of the values of the x and y axis would be defined to you. You would just take that particular point and calculate the x's and y's. You basically would be given the values of x's and y, x1, x1, x2, and y1, y2, and you can just use that, put it in the formula, and find the distance. But here we are asked the Manhattan distance, which is easier to calculate. That's why we are going to follow the Manhattan distance. So Meenal asks, can J be the highest value? So let's check it whether J is the highest value or not. So let's count the number of boxes that we are going to traverse when we consider the Manhattan distance from J to the goal node. Let me first erase this. Okay, I'm just taking a bit of a time to get this heuristic question sorted because the next questions are going to be based on this. Okay, so if this is clear to everyone, then it will be easier to answer the next question. Okay, so from J we can go this way: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, and 19. Okay, so 19 into 10, 190 is the heuristic value for J, whereas for A it was 220, right? So yeah, sorry about that. So again, J does not have the highest heuristic value. Okay. Yeah, yes, Rocky, we cannot calculate Euclidean distance using this block distances. That has a different way to we have a different way to calculate Euclidean distances. If you just make a simple Google search, you'll understand how you calculate Euclidean distances. Or maybe I'll also give a simple example. But before that, just to address Samanthi, you can get the answers of each week's assignment once the assignment's due date has passed. Okay, so let me just clear this and draw a simple coordinate system to clarify this. Okay. So let's say this is your origin. Okay, this is your x-axis. This is your y-axis. Okay. This is, let's say, 1. This is, let's say, 2. This is 3. Similarly, this is 1. This is 2. This is 3. We are considering only the positive space. Okay, we're not going into the negative space because that doesn't make sense for the distances. Sorry about that. Okay, so let's say there is a point over here. Okay, this one. If we have to calculate the Manhattan distance, the number of blocks that we are going to have to cover is this way 1, this way 2, 3, and 4. Okay, and now since here we have defined each block to be of size 1 unit, the Manhattan distance would be 4 units. Now, if we have to use the Euclidean distance, let's call this point O. Okay, this is O, and the coordinates are 0, 0. Let's call this as A. These coordinates are 2, 2, right? Because this is, we are moving 2 steps in the right direction and 2 steps in the upward direction, right? Or if you can consider it this way, we are moving 2 steps in the upward direction and 2 steps in the right direction. So 2, 2. So what will be your Euclidean distance? It will be root over 0 minus 2 whole square plus 0 minus 2 whole square. Okay. Use any calculator or hand calculate it and you will get the value. That will be your heuristic value if you used a Euclidean distance. So I hope that clarifies the doubt about Euclidean and this Manhattan distance. Yeah, so yes, Hina, we only calculate the heuristic value with respect to the goal node. Because as I was mentioning earlier, it is intuitive to do that because we want the heuristic value to be a measure of how close we are getting to the goal node. Okay. Yeah, thanks, Dr. Ashwini, for pointing that out. I think it was because someone might have muted by mistake, and yeah, I think there shouldn't be an echo anymore. Someone had unmuted. Sorry about that. Yeah. Okay, so now let's move on to the fourth question. Okay, so in the previous question, we found out which node has the highest or the largest heuristic value. In this question, we have to decide which one of the nodes has the smallest non-zero heuristic value. And we have to report what is the heuristic value. Okay, and the question also mentioned that if there are multiple nodes with the smallest heuristic value, then we may choose any of those nodes to report our answer. Okay, and the reason why we are told non-zero heuristic value, because the heuristic value for the goal node itself will always be 0. Okay, because once you have arrived at the goal node, you know that you have optimized your solution. You don't, your heuristic value will tell that it's 0 already. You don't need to minimize it any further. Okay.
Sir, don't mind, sir. I would like to know how H1, H2 are calculated. Please, can you?
Yeah, so these H1, H2 basically refer to the heuristic values for different nodes, right? Which we calculated using the Manhattan distance that I just showed. Right? Is that what you're asking, or is it specific to some particular algorithm?
Yeah, it is for 8 puzzle problem.
Okay.
Don't mind, sir, because I am not able to get that.
Yeah, sure. So can you specify the exact question that you want to ask?
See, we are being given in the last assignment that we are being given A, B, C, D, E, F are the states of the 8 puzzle problem.
Okay.
And we are supposed to find H1, H2, H3 and H4.
Okay.
So how to calculate with respect to H1 is the number of tiles which are arranged in a wrong position.
Okay, so now see, heuristic value can be dependent on the problem that you are solving. Okay, so now since you are mentioning that you are solving the 8 puzzle problem, there the heuristic value, which H can be H1, H2, H3, whatever, that will be defined by a different logic, different formulation that you are just talking about, the number of tiles that are not in position. Okay.
Yes, sir.
Here the problem itself is different. Okay, here we are defining the heuristic value using Manhattan distance, which is the distance between two particular points on this map, right?
we are asked to find Manhattan distance for the problem also.
For the problem that you are mentioning, that one also.
Yeah.
Ma'am,
Okay.
in that the 8% problem, we are already given a goal state. You just have to compare this heuristic value of individual tiles with the goal state. Like you are taking a state that is given in the question. You just have to compare, just sum up the all the wrong tiles that are placed with the heuristic difference to the goal state. That is it.
Thank you, sir. I got the hint to solve the problem. That it is must ensure that G should be the same for all all the states which are being given, right?
Yeah, G is the goal
Okay.
state mentioned there.
Thank you, sir. Thank you. Sorry to disturb you, sir. You please
No
continue.
worries. Yeah. Thanks, Ankit, for addressing that. Yeah. Thanks a lot. Yeah, and I think we are going to discuss one more problem towards the end where we are going to define our heuristic value in a slightly different manner because the problem would be different. And I think if there is any residual doubt after Ankit's explanation, then that should clarify it. Okay. Yeah, Kesar, I'll zoom on the map. Um, okay. Okay, Harshvardhan. So we have discussed DFS at length in the previous live session. I would really not want to revisit again. So if we have time left after today's live session towards the end of it, I can revisit it again. But if there is not enough time, you can just go back to the previous live session recordings, and we have discussed it at length. So that should help. Yeah. Okay. So some of you have provided the answer, and yeah, glad to see that you all are correct. So y is the correct answer because y has the smallest heuristic value which we calculated was 30. And if you see any other calculate the heuristic value for all other nodes, you'll see that all of them are greater than 30. Okay, so the y is our node with the smallest non-zero heuristic value, and that is the correct answer. So yeah, great work all of you. And let's quickly move on to the fifth question then. Okay, so now we are going to use a different method for different algorithm than what we have been using thus far. Okay, we have thus far been using the depth first and the breadth first search, or DBDFS or DFID or whatever. Now we are going to use heuristic based algorithms. Okay, and this particular algorithm is called best first search algorithm. Okay, so what this one will do when it is inspecting a particular node, okay, say suppose it is at this node S. Okay, it is going to look at the heuristic values of all the nodes that it could go to from here, which in this case are E, J, K, and O. Okay, so let's first calculate the heuristic value for all these nodes. So for the S node, let's calculate it for S node as well. It's 1 block, 2, 3, 4, 5, 6. Okay, let me do it properly. 1, 2, 3, 4, 5, 6, 7, 8, 9, 11, 12, 13, 14, 15. Okay, so also feel free to correct me if I'm making a mistake in calculating the heuristic value. It is 160, not 150. Okay. Okay, so the heuristic value for S is 160. For J, it would be 190. Okay, let's remove this. For K, it would be, let's see, it would be 120, right? let me just verify. It's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Yeah, it will be 120 for K. And the only node left now is O. So let's calculate for that. It will be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. So 120 again. Can you just verify whether my calculation was correct and whether you're also getting the same values? We are left with E, right? Yeah, thanks for pointing that out. We'll calculate E also. So for E, it would be 1, 2, 3, 4,
170.
170. Okay, thanks for that. That saves us a lot of time. Okay, so now, now that we have calculated the heuristic values of all the nodes that we could go to from S, let's go back and check if the question mentioned any particular assumptions. Okay, so here is when one of the assumptions of the question would come in handy. So here it is said to us that during inspection, if multiple candidate nodes have the same estimated cost, then we are going to choose that node to inspect which comes first in the alphabetical order. Okay. And the question asks us to list the first 7 nodes inspected, or if the algorithm terminates, we have to stop there and report all the nodes inspected. So this assumption comes in handy because we see that 2 of these nodes that we could go to from S, O and K, they both have the same heuristic value. Okay. And now since we are told that we have to choose to inspect the node which comes first in the alphabetical order, we will choose to go for K, right? And 190 and 170 are the heuristic values for J and D, which are in any ways greater than the heuristic values for O and K. So we are not going to consider those. So after S, we are going to inspect or evaluate K. Okay. So is that step clear?
Yes.
Okay. Thanks for that. Okay. So now we are at K. Okay. So let's okay, yeah. So one other thing, why we are choosing the least value, because that is the best that is the best looking solution at this point, right? So that is why the algorithm is named best first search, because it chooses to go in the direction of the best looking value at that particular point of time. So if I just explain it once more, so we are at S, which has a heuristic value of 160. It wouldn't make sense to go to a node that has an even higher heuristic value, right? So it wouldn't make sense to go to E because it has a higher heuristic value. It wouldn't make sense to go to J, which has a higher heuristic value. It would go to either O and K, and by your assumption, we are choosing to go to K. Okay, so now we are at K, and from K we could go to F, H, L, Q, right? So let's calculate the heuristic values for each of these. If you have already calculated it, okay, so thanks for doing that. Some of you are telling me that. So for F, it's 150. Dr. Ashwini says it's 150. Thanks for that. Okay. What is the value for Q? Has anyone found that? Okay, so for H, it's 90. Ankit says, thanks for that, Ankit. Okay, for L, it should be 80, I think, right? Yeah, for L, it's 80. Thanks, Lasya, for that. And for Q, 90 again. Thanks, Harshvardhan. Okay. So now we were at K. The possible options we have are we could either go to. So first, let us look at what are the nodes with a lesser heuristic value. Okay, so we are discarding F because F already has a higher heuristic value than K. Okay, so we're not considering F anyway. We could go to Q, L, or H, but out of these, L has the least amount of least heuristic value, right? So we will choose to go to L. So now we are at L. Okay. Now here comes another particular subtlety about this best first algorithm. Okay. So best first algorithm will only move ahead when it sees that there is a better option ahead, right? But here we see once we are at L, it all the places that we could go to from L have a higher heuristic value, right? So L is connected to K, which has a higher heuristic value of 120. L is connected to H, which has a higher heuristic value of 90, right? So it will get stuck over there. Uh, that is not the case. So again, I am wrong about it. So sorry about that. Yeah, so that is how the hill climbing algorithm works, not the best first looking solution. Um, okay. Let me just check whether we calculated our values in the correct manner. Yeah, that seems to be correct. Okay. Then what should we do is let me just quickly go to the lecture notes and clarify. Okay, sorry about the delay. I just want to make sure that I'm not making a mistake with the best first and the hill climbing algorithm. Just give me a moment, okay? Okay. So here is the triviality that I was missing. Since we are using a priority queue, right? We can still move ahead from L to the best looking option that is there from there. Okay, let me just quickly. Yeah, so that's right, Rocky. It would choose the best node through which it could access. Yeah, that's why it'll. Yeah, so sorry about the confusion earlier. Um, from L, it'll go to H basically, because that is the best looking path from there on, and since it is maintaining a priority queue. Okay, so it'll from L, it'll go to H again because H and Q are the possible option that it'll go to. Okay, and yeah, that's where it'll go, and from H it can go to M, I, or C. Okay, so let's calculate the distances for those, which is 1, 2, 3, 4, and 5. So this is 50. Then I is 60 as we had calculated. C would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. This would be 140 and P would be 1, 2, 3, 4 and 40. Okay. So once it is at H, it will go to, okay, we didn't need to calculate P as of now, but anyway. From H it will go to M. Okay. From M it could go to I and P. So it will choose to go to P. And from P it has the one simple path to G, which has a 0 heuristic value. So it will go to G. So those would be the nodes inspected. So S, K, L, H, M, P, and then G. Does it make it 7 nodes? 1, 2, 3, 4, 5, 6, and 7. Yeah. That is why the answer is SKLHMPG. Okay. So yeah, the point that I was missing earlier, which we saw because of we visited the nodes, is that I was getting confused between best first search and hill climbing algorithm. So hill climbing algorithm in this case would have gotten stuck at L. Okay, because hill climbing will specifically only move if there is a promising looking solution. But best first search will move ahead with whatever best looking option it has at that point of time.
Sir,
So
I have a doubt.
yeah,
Sir, will it stop at L if it is a hill climbing algorithm like SKL?
yeah, that's what I was trying to show. In the next question, we were about to discuss the hill climbing algorithm itself, and there we will see that it will stop at SKL.
Okay, sir.
Yeah, because it cannot go any further, because there we are strictly moving only in those directions that are giving us a promising solution, like by a strict measure. Yeah,
Yes, sir. Okay, sir. Thank you.
yeah. Thanks for the question, Sandhya. Yeah, but every heuristic value must be calculated with respect to the goal node only. Okay. Yeah, very sorry about the confusion earlier, and I hope this is clearer now. Um, so we have discussed one more question actually, which was the hill climbing algorithm, which, as you some of you pointed out, will stop at L, so it will be SKL. Okay.
So one question actually.
Yeah, Dr.
What
Ashwini.
is what is priority queue?
So priority queue is a queue with a certain modific. Okay. Vijay, can you please mute yourself if you don't get the question? Okay. Yeah. So priority queue is a special kind of queue where each element is assigned a particular priority, basically a priority value, and then elements are inserted into the queue according to that priority. And the priority value in that case, in this case, would be the heuristic value. Does that answer your question, Dr. Ashwini? Okay. Yeah, so Vijay, you had raised your hand. There is certain noise in your audio from some background, I think. So if you have a question, if you can write in the chat, it will be great. Or if you can avoid that particular background noise, and then you can please feel free to unmute yourself. So Likita, is your query clear now after discussing the solution, or do you still have a confusion between best first search and hill climbing? So the thing to remember here is that hill climbing will specifically only go for solutions which are strictly better. Okay, but when best first search, since we're using the priority queue, we have that option of when we have, if for example, when we were at L, we were inspecting L, we had that option to also go to H. Okay.
ಸೆಟ್ ಆಗೋಯ್ತಲ್ಲ.
Can you hear me, Likita? Okay, maybe there is a connectivity issue, and that's fine. Okay. Okay, let me explain it in a certain different way. Okay. So we are starting from S, okay? Let me actually make this on a different clear path. We were starting from S, okay? There, what were the options we had? We had E, J, K, and O. Okay. Now, we chose to visit K. Okay. Now, when we are at K, what are the options that we have? We have F, H, L, and Q. Okay. Out of which L looks the most promising. Okay. With a lesser solution, with a lesser heuristic value. So we went to S. So we went to L. Okay. But now we saw that from L we can go to only H, right? Which at this point would already be present in the priority queue, right? So we find we are at a situation where there is no way for us to add further to this solution tree. Okay, so what we do is we follow the priority queue which would have had H at its front at that point of time. Okay, so our queue would have looked something like this. L would have been present with 80, H would have been present with 90, then Q would have been present with 90, and F would have been present with a certain value, whatever it had, 150 or something, right? Yeah. So once we saw that from L we can't go any further, the next possible option is to go to H, which is the better looking option over here, right? The best out of the possible options available to us. We could also go to Q, which has the same heuristic value, but H comes alphabetically before Q. So we inspect H next, and then we see what are the places we could go to from H. Right? From H we could go to M, I, L, C, and all those things. Okay. I'm not writing it again in the tree. Okay. We see that M has the least heuristic value among all these. So we inspect M next. Okay. Again from M we see that P has the least heuristic value. So we go to P. And then from P we see that G has the least heuristic value. So we go to G. But what is happening in case of hill climbing is that, so we start from S. Okay. Hill climbing will only go to places which are better, exclusively better than this. Okay. So when we draw the solution tree, it would be something like this. So from S, the exclusively better options are K and O. K and O. We choose to go to K because K is alphabetically before O. Okay. Let me also just write down the heuristic values. Okay. Now from K, what are our options? From K, we could go to Q, L, and H, because those are the only ones with lesser heuristic values. Okay, so Q has 90, L has 80, H has 90. Okay, L is the one with the least heuristic value, right? So we inspect L. Okay, but now due to our restriction that from L we can only move ahead to places that have an exclusively lesser value than 80. We cannot from L we can only go to K and H, right? Those are the only two things connected to L, both of which have a higher heuristic value. So we can't draw this solution tree further only. Okay, so it will get stuck and it will terminate over here. That is why hill climbing is getting stuck at SKL. Whereas for best first search, we went through SKL, then H, M, P, and then G. So does that help with the explanation? Yeah, here we are trying to minimize our heuristic value. So that's why we're choosing one with a lesser heuristic value. If there is some problem for which we need to maximize the heuristic value, I'm not sure what kind of problem would be that. Would that be? I have to think about it. But yeah, if it is a maximization problem, we'll move to higher heuristic value. Yeah, no need to say sorry for that. There can be problems with a higher heuristic value where we have to move to a higher heuristic value. I'm not exactly sure which problem. Maybe we'll see it in the coming slides or in the coming lectures. Okay. Okay, yeah, thanks for your question, Rocky and Bharatwaj, and all of you had asked the question. And sorry if I missed any of your questions in the chat box, but I hope this is clear by now. Rajdeep, you had unmuted. Did you have a question? Okay, maybe not. Okay, so now let's go back to our questions. And sorry, sorry about that. Okay, and let me just introduce the next question and then so now we are arriving at a different kind of problem. Okay, so consider this SAT problem. Okay, so basically you are given a particular formula F. Okay, and these symbols basically mean and or. Okay, so this V looking symbol is basically or, and the A looking symbol is and. Okay, and this thing in front of B over here, this is the not symbol. I think most of you would be familiar with this notation already. So basically A, B, C, D and E are 5 variables that can take values either 0 or 1. Okay, and accordingly these can have a number of configurations. Okay, A can have 0, B can have 1, B can be 0, so on and so forth. And based on the configuration of the values of A, B, C, D and E, this particular formula F would have another value. Okay, so here what you have to do is you're given a particular configuration of A, B, C, D and E to start with, which is 1 0 0 0 0. So let us write it down. Okay, so 1, this is the start state that is given to you, which basically means that A has the value 1, B has the value 0, C has the value 0, D has the value 0 and E has the value 0. Okay, and if we evaluate our function based on this, we have to see what do we get. Okay, so let's just do that. This is the formula that we have, and let's just paste it over here. Okay, okay, looks like that doesn't work over here. Anyway, we can just simply write it down. Sorry about that. Okay, so our first bracket is A or not of B. A or not of B. And not A or D. and B or C. And B or D, and not C or not D, and C or E. Okay. Now following simple Boolean logic, if A is 1, then this will be basically 1. Since B is 0, not of B will be 1, and 1 or 1 will give us 1, right? So this particular bracket will evaluate to 1. Now let's consider this one. Not A would be 0, right? And 0 or anything would be 0. So this would be evaluating to 0. Similarly, B or C will evaluate to 0. B or D will evaluate to 0. Not C or not D would evaluate to 1. And C or E will evaluate to 0. Okay, so is this much clear? Okay, great.
Yes.
Thanks for that. Let's revisit the question then. Okay. What we are told in the question is, if we begin from this particular configuration of A, B, C, D, E, then we can, the next states that we could go to from this particular state would be defined by flipping one bit. Basically, that means that we started with 1 and 4 zeros. If we flip each bit of this particular 5-digit number, if we flip the first bit, we would have 5 zeros, right? If we flip the second bit, we would have 1 1 and then 3 zeros. If we flip the third bit, we would have 1 0 1 0 0. If we flip the fourth bit, we would have 1 0 0 1 0. And if we flip the fifth bit, it would be 1 0 0 0 1. So these are the possible states that we could go to from this particular state that is given to us by flipping one bit at a time. And the heuristic value in this case would be defined by the number of these clauses. So clauses basically here refers to each of these small brackets that have been evaluating to 1. Okay, and so this is where this maximization comes in. So Rocky, you were talking about a problem where we would have to maximize our heuristic function. So this is one example of that kind of an equation. Okay, so the heuristic function in this case, heuristic value would be defined by the number of these small brackets that have been satisfied, or basically that have a evaluation of 1. So as we saw with this 1 and 4 zeros configuration, there were 2 clauses that were satisfied, right? So the heuristic value for this particular node, these 2 clauses would be 2. 1 plus 1, 2. Okay, so this one will have an heuristic value of 2. Okay. Similarly, let's consider this particular configuration. If all of them are 0, so let's write this down. Okay, so if all of them are 0, let's make this 0, then this would be A or not B. Not B would be 1, so this would again evaluate to 1. Okay, this would also evaluate to 1. This would be 0, this would be 0, this would be 1, and this would be 0. Okay, so here we see that 3 of these small brackets or 3 clauses are evaluating to 1 or are getting satisfied. right? So for this one, the heuristic value would be 3. Similarly, calculate all the heuristic values for each of these states, and that is what is asked in the question. Okay, so we are giving each of these a name to each of these states depending upon the value of the position of the bit that we are flipping. Okay, so if we are flipping the value of the A variable, we are calling that SA. If you are flipping the value of the B variable, we're calling it SB. So similarly, we have SA, SB, SC, SD, and SE. Okay, and we have to calculate the heuristic value for each of these. So you already calculated the heuristic value for two of these, which is SA and S and SA. I'll give you some time to calculate the heuristic values for SB, SC, SD, and SE. Okay. Okay, yeah. So Rocky, you're asking what would be the answer if there are three variables under a single clause. Okay, so if there are three variables under a single clause, you would calculate similarly. You would find the value of that particular clause and give the particular answer, right? So and or these are commutative, right? So if you had something like A or B or C, something like this, you would simply do A or B first and then the result of that or C. Okay, but you don't need to worry about that because these SAT problems need to have the formula defined in a certain manner. Okay, and for that you will always be given the formula in the format that it is required. So yeah, but your question is a valid question and I hope I address that. So you would just use the commutative property of and in our operations. Okay. So thanks, Dr. Ashwini. You have given us some answers. 3, 5, and 4. Okay. So Aditya, CNF refers to conjunctive normal form. Basically, you see that there is a and operator between all these small clauses, right? Which basically means it's a conjunction. So this is basically particular notation. That's why it is called conjunctive normal form. Okay, so
can you explain it again?
sure. Let me do something like this. Can you maybe mute yourself? Thanks for that. Okay, so whenever in doubt, you can always refer to this vast internet we have. Okay, so conjunctive normal form is a specific kind of notation in Boolean logic. Okay, where you define your formula as an and of different clauses. Each of these clauses will be an or of different variables. Okay, those variables can be like a variable v itself or a not of that variable. Okay, so these are some examples. So for each of them you will see that there is an and connecting two small brackets, and each of these small brackets are connected, the variables are connected by an or. Okay, so this is how a conjunctive normal form is defined. Does that answer your question, Ravi?
Yes, sir.
Okay.
We'll go through this.
Okay, yeah, great. You could go through that. And also thanks for your question, Aditya. Okay, so now some of you have already shared your answers to this particular problem. Let's check the answer. Okay, so the heuristic value for S and SA, as we found, were 2 and 3. For the rest of them, it will be 4, 4, 4, and 3. So let's just write that down. It will be 4, 4, 4, and 3. Okay.
Sir, what is beam? There is a question that is mentioned in the assignment.
What is?
Beam. Beam. Actually,
Beam.
determine the two
Okay.
nodes in level.
Okay, so beam, okay, you might be referring to this beam search method, is it?
Okay, is it beam search method? Okay.
Let me just
Okay,
verify
sir.
it. It's from this week 3, right?
Yes, sir.
Okay. Okay. It's not in this particular slide. Let me just check the other slides. Yeah, it's this beam search. That beam must be referring to this beam search method. And yeah, that is in context of the SAT problem.
Okay, sir. Thank you.
Yeah. Okay. So yeah, that basically brings us to the end of the questions for the day from week 3. And yeah, just to kind of conclude, sorry, give a conclusion of this particular problem. So here we are, what we intend to do is we intend to find a formula, find a configuration for which the formula, that is f, that is given to us, this f evaluates to 1. Okay, so that basically SAT means satisfiability, right? So we want this formula to be satisfied. And for that to happen, since all of these small brackets are connected by AND, all of these small brackets will have to evaluate to 1. Then only this formula will evaluate to 1. Okay. So we have to find a configuration where the heuristic value reaches how many clauses are there? So we have 1, 2, 3, 4, 5, 6 clauses. So the heuristic value must come to 6. So here we would go to the most promising looking solution from this point. Okay, so we were at a node which had a heuristic value of 2. We would like to go to a next node which has the highest possible heuristic value, which could be any of these 3 nodes. Okay, you can decide that based on the algorithm that you are using, and from there on, let's say you choose to go with this particular the middle node, then you again invert the bits one by one, and then you again arrive at 5 possible states that you could go to, and you again evaluate the heuristic values for each of these states. Maybe some of them would be 4, some of them would be 3, some of them would be 6, let's say. So then you again go to the one with the highest heuristic value. Okay, and maybe that is the one that will satisfy your problem. So yeah, that is how you're going to proceed.
So for this kind of SAT problems, cannot we just do like each the terms that are in CNF? We can just draw the options available, like just for each the quantities that are within the brackets, and just calculate for individual bracket itself. That will prevent us from constructing a too much large of a tree, and it will also be a short.
Okay, yeah, you're talking about optimizing in terms of the search tree. You mean to say that we consider these small brackets one at a time, right?
Yeah.
Okay. So the issue, if you see with that, is with a certain configuration, let's say with this configuration itself, where all A, B, C, D, E are all zeros. Okay.
Okay.
This clause evaluates to 1, this evaluates to 1, this evaluates to 1. So we would think that these 3 are solved. But with the same configuration, these 3 are not solved, right? There are 3 clauses that are still not solved. So, and what do we want? We want all of these clauses to evaluate to 1. So in order to keep track of that, you need a kind of method that considers all the particular clauses, right? That's why we are defining the heuristic value in such a way that it is a summation of the whether each of these clauses have been solved or not.
That thing would not have created problem if we don't have any this ABCDE anything common across two brackets, but because there are some common, that's why we have to look into in this
Okay, you
method.
mean to say something like, let's say you had something like A or B and C or D, something like this, you mean?
A or yeah, Yeah, in that case, are we free to go, or do we still have any challenges?
But you still need to keep track of whether these two are satisfied together or not, right? You need to check whether each of these individual clauses are satisfied together, not just independently. Because for some configuration, you might have that this clause is satisfied but this clause is not satisfied. Yeah, what you could do if you have this particular case where each of these clause has a variables that are not present in any of the other clauses, then you could kind of break down your let's say there is one more which is E over here. You could break down your candidate solution or your state into different possible configurations. Let's say you have 0 0 0 0 0 for A, B, C, D, and E. So the first clause has only A, B, second clause has C, D, and then you have E. So this will become one subpart of the candidate solution, one subpart of the candidate solution, one subpart of the candidate solution. Okay. But eventually,
Yes, sir.
to see whether your formula F prime is getting satisfied or not, you will have to formulate some way or some criteria to check whether each of these clauses together are satisfied or not.
So because there is an and in between all the three clauses,
Yeah,
if all the three are individually satisfied, that means that F dash also is also satisfied.
yeah, this because there is an and, all of these clauses have to be satisfied simultaneously. If this had been an or, then if any of them would have been satisfied, you could have said that, okay, now my F prime is satisfied. But that is not the conjunctive normal form, right? That is, so and SAT problems are defined in that CNF form.
I got it,
So
sir.
yeah, that's why basically this whole issue. But yeah, thanks for your question. That was a nice question. Okay, so coming back to a few doubts from the very beginning of the session. So let me just quickly check whether some of you were asking doubts about the traveling salesman problem, right? So let me just go back to the traveling salesman problem. So this is how a traveling salesman problem is defined. Given a set of cities and given a distance measure between every pair of cities, the task is to find a Hamiltonian cycle having the least cost, which basically means that you have to find a way. Okay, you start from any particular node. You find a way to visit each and every of the other node and arrive at the node that you started to. And each of these paths or each of these cycles will have a certain cost associated with it. Okay, so for example, the cost of going from this particular node, okay, let's say this node, which is at the topmost, to the second topmost node is just say 10. Okay, so that would add 10 to the cost. Then again from the second node to the third node the cost is 20, so then the cost would become 30. And you do that, add up all the cost for all the edges of the cycle, and that would give you a particular cost. Okay, and that would be the cost for this particular cycle. You have to find a specific cycle that covers all the nodes and at the same time also has the least amount of cost. That is what the traveling salesman problem is. Okay, there are a number of ways to solve this particular problem. You will see some of them in this lecture. Some of them you will also see in the coming week also. Okay, which would be this particular module, I think, the stochastic local search. I'm not sure if that has been covered yet. Let me just check it. Okay, it is there, so that's good.
So it's
Yeah. Yeah, so there are a number of methods like taboo search that you could use to uh, find your optimal solution. That could be applicable to the SAT problem, that could be applicable to the TSP problem as well. Uh, yeah, simulated annealing is another method. There are population based methods. I don't think this has been covered now because I think this is supposed to be covered in the 4th week. Or has it been covered? Can any one of you confirm?
No, sir, no. No, sir, it is not covered.
So basic idea of this is covered, but like population, etc. This type of topic will be covered in the upcoming weeks.
Okay, yeah, then that's fine. We can have a in-depth discussion about TSP and how to solve it using population based on other methods in the next live session then, because we are already nearing the end of today's session. And yeah, once again, so the doubts that were about DFS and DFID, yeah, so we are at a shortage of time, so I'm not going to cover DFS. For that, I would recommend you to go back to the previous live session. For DFID, again, I had in the last live session pointed you to some of the practice questions that were uploaded by Bhaskaran sir in this lecture materials, right? So yeah, now we don't have time, so maybe again in the next live session, if we have time, we can go over it. But I think there should be enough practice problems in the folder that Bhaskaran sir had shared. So have you gone through it? First of all, those who were asking about the DFID method. Is anyone present in the meeting still who was asking a doubt about the DFID method?
Ritvij, hello.
Yeah, can you hear me?
Yeah. So, can you give an example on a traveling salesman problem? There is a question in assignment.
Mm-hmm.
So I have posted in the chart.
Okay. Can you post it again, maybe?
Okay.
I think I missed it.
I posted.
Okay. This one, right? The given city map starting from S and using only the given edges and using Euclidean distance as the edge cost. Construct a TSP tour using the nearest neighbor algorithm. Use node labels to break the ties. Okay.
So they have given
yeah.
a diagram, a graph.
Mm-hmm.
As you have given a graph initially, right? Similarly, a graph is given.
Okay. And you have to apply the nearest neighbor algorithm to find a solution. Is that the question?
Yeah.
Okay. So once again, let me check if there have been practice problems on this that have been uploaded by Bhaskaran sir.
One more request.
Yeah.
Could you please share the recording before assignment because I want to revise?
Yeah, I will.
Last week, okay, it has been posted after the assignment.
Yeah, I know there was a technical issue because of which the delay happened. It won't happen to the best of my ability.
From channel also, it is showing as hidden actually.
Yeah, I understand.
In the playlist.
Yeah, I understand. So I would recommend one thing. Okay. I would recommend one thing. So let me just show that to you right now. Since this is a rerun of a course, one advantage that you have is that you can always revisit the recordings from the previous run of the course that are also present in the same YouTube channel. I'm not saying that you have to. I will try my best to upload the live session recordings by maximum tomorrow. Okay. But I'll just show what I wanted to show to you. If you just go to this YouTube channel, you will find a playlist from the previous run of this same course. Okay, while this loads, I'll
we
quickly.
have 3 playlists.
Yeah, you found that one of them would be on SMPS, and that will have a similar or same problems and their explanations.
Yeah.
So you can also revisit those.
Oh.
Okay, but anyway, I will try my best to get the recordings uploaded before the assignment deadline. Sometimes there are these technical
Yeah,
issues
Wednesday is
that
the
are
last date.
not in my hand, right? So there are sometimes that issues might happen. So yeah, thanks for understanding that.
And one more request. Assignment solutions are not yet updated.
Okay. Oh, you
In the
mean in that?
portal.
You mean the solutions of the
That's why
assignments that for which the due date has
yeah,
passed?
yeah, assignment 1 and 2. Assignment 1 and 2.
Oh, is it? Let me check.
No.
Are you referring to these solutions, or you mean like in-depth solutions?
So week 2 assignment. So generally they will give assignment solutions, no?
You mean the in-depth solutions from the discussion forum, you mean, right?
No, actually they will upload a PDF of solutions. In other courses, they will upload the PDF of the solutions. Why that is correct like that?
Okay, yeah, so different courses follow different approaches. For this course, what I have observed is what if you go to the discussion forum, Bhaskar and sir will usually be uploading the solutions in the discussion forum. Okay, so if he hasn't done that till now, you can maybe quickly write a message to him in the discussion forum saying that you are expecting the solutions for a specific question, and he will for sure get back to you. I will also contact him from my end and just give him a gentle reminder to post the solutions in the discussion forum. And I hope that will help. Okay.
Thank you. Thank you.
Yeah. And coming back to your query on the example, I think you might have something over here. This is best first search. This is breadth first search. Okay, this is depth first. This is hill climbing. This is beam search. Okay.
Your screen is not okay.
Yeah, I was just going through this drive folder basically.
Okay.
Yeah.
Okay. No,
Okay, it doesn't seem like it has a nearest neighbor thing over here. Let me just check the assignment. So you are not asked about the nearest neighbor anywhere over here, right? Okay, here is the one. Okay, so here it asked about, okay, first of all, I'm not supposed to discuss this. So because this is the current assignment before due date. So I'm not going to discuss the answer for sure. But what I would suggest is that since this is not a solution as such, it is an intuition of or the test your understanding of the nearest neighbor algorithm. Just go through the algorithm steps. I'm sure the algorithm the pseudo code for the algorithm would have been given in the lecture notes. So just go through that, and that should be helpful for you to answer this question. Okay, and maybe next week we can discuss this in more detail.
Okay. Thank you.
Yeah. Thank you. So yeah, so we are already past our time. So I will yeah, if there are no further doubts, I see there are some logistic related doubts on the chat box. So again, for that, you can post the logistic related doubts in the discussion forum, and then the NPTEL team would be a better person to address that. Also, you should share your feedback on the practice problems that have been uploaded in the lecture material drive folder by Bhaskaran sir. So he was asking me to convey this message that you can share your feedback on whether these practice problems are helpful, whether they are too tough, whether they are too simple. You can post that feedback in the discussion forum, and he will take that feedback and incorporate that into the practice problems for the upcoming weeks and upcoming runs of the course. Okay, so yeah, thank you all for attending. Thank you for your patience, and have a good rest of the evening, and let's meet next week.
Thank you for the session, sir.
Yeah, thanks for attending.